Hello everyone, welcome back. In this lecture we want to discuss evaluating logarithms. So we have logarithm of 4 to the base 2. We want to know what is the answer. So basically we are looking for an exponent for 2. We're looking for a number that 2 is raised to that exponent, and then the answer is 4. Basically that's coming from the definition of logarithm. So now the question is, what is that exponent? That when you raise 2 to that exponent, you end up with 4. And everybody knows that 2 squared is equal to 4, because 2 times 2 is 4. So the answer is 2. So log of 4 base 2 is equal to 2, because 2, we can say because 2 to the exponent of 2 is equal to 4, obviously. So if somebody asks you what is log of 4 base 2, the answer is simply 2. That's what it is. Okay? So this tells us something, that a logarithm is actually nothing but an exponent. Okay, a logarithm, this number 2, which is the outcome of this logarithmic expression, is actually nothing but an exponent. That the base 2 has to be raised to that exponent in order to give us 4, which is the number you're taking its logarithm. Next question is log of negative 4. Well, log of negative 4, like it's clear that it's undefined and it doesn't exist, because if you remember the graph of the logarithmic function, it was like this. It was always on the right hand side of the y-axis, so we didn't have any part of the graph on the left hand side of the y-axis, let alone being like passing through negative 4. So logarithm of negative numbers and logarithm of 0 is always undefined, something you may want to remember. Only logarithm of positive numbers is defined, period. So for this, there is no answer. We move on. Log of 64 equals 4. We said that log is an exponent. So the question is 4 raised to what exponent equals 64? Obviously, the answer is 3, because 4 cubed is 64. Next one, it's a fraction. So log of 1 over 27 base 3 equals what? Basically, 3, the base raised to exponent of what number, would be 1 over 27. Well, I would say the answer is 3 if I have 27, because 3 cubed is 27. But unfortunately, we don't have 27. We have 1 over 27, which is actually 27 raised to exponent of negative 1. So that tells me that the answer must be negative 3. And this tells me that actually 3 to the exponent of negative 3 is 1 over 27, because we know that any number raised to a negative exponent equals to the reciprocal of the same number with positive exponent, and that would be 1 over 27 clearly. This one is a cube root of 25. Log of cube root of 25 base 5 is equal to what? And I don't know if you know this or not, I'm not even using a calculator. I don't need a calculator. So this one, I'm going to say the following. I'm going to say this is basically log of cube root of 5 squared when you think about it, okay? And when you have cube root of 5 squared, you can express this radical in the form of the base with a rational exponent, that is 2/3. So it's needless to say that 5 raised to the exponent of 2/3 is equal to the cube root of 5 squared, basically. And now the question is 5 raised to the exponent of what would equal to 5 to the exponent of 2/3? And obviously the answer is 2/3 itself. So that's how you take care of this question. Next one, it says log of 1 base of 675. It's a big base. There must be some trick going on here. Well, the thing is that it doesn't matter if you have 675 or 6,000,005, whatever you have. Any number raised to the exponent of 0 is equal to 1. Therefore, logarithm of 1 to any base, whether 675 or 674, whatever, is always going to be 0. And this reminds me of a formula that I can write down here. I can say log of 1 to any base b is equal to 0. And I come up with a formula, a general formula, saying that whatever the base is, of course positive, log of 1 to any base is equal to 0, because that base raised to the exponent of 0 is equal to 1. So we came up with a formula actually. And next one says ln of 1. Well, ln of 1 is nothing but a log of 1, but just the base is e. And it doesn't matter if the base is 675 or it's e or whatever it is. I just said it 2 minutes ago. The answer is going to be 0 anyway. What if the base is pi? Well, it doesn't matter. Again, pi raised to the exponent of 0 is equal to 1. And this one is a little bit different. It says log of 1729 to the base 1729. So this time, I can't say the answer is 0, but I can say one thing. Because the base of logarithm and the number in the argument of logarithm are both the same, so I say the answer is 1. You're saying why? Because the base raised to the exponent of 1 and only 1 equals to the same number. So I can come up with this formula. I can say log of b to the base b is always equal to 1. And you may say, well, this is common sense, obviously. And it is common sense. Because the base b raised to the exponent of 1 is not going to be something else other than b itself. Don't we know that any number raised to the exponent of 1 is equal to itself? Is it not true that 7 to the exponent of 1 is actually 7, not like 49? So we come up with like general formulas that we can use in future. I continue. 8 raised to the exponent of log of x base 8. Well, the exponent happens to be a logarithm itself. So I don't know what the answer is. So I'm going to call it a y or something. Okay? I'm going to call it y. I'm going to say, okay, this power, I should say, with the base of 8 and exponent of log x base 8 is equal to y. But then I can say something. This is the exponential form of logarithmic form, basically. I can say log of y to the base 8 equals log of x base 8. I can say that, because 8 raised to the exponent of the logarithm equals y, and that's exactly what we have here. If you remember, we learned in the past how to convert the exponential form in logarithmic forms back and forth, and I'm assuming you have practiced enough on that, so you understand here. Now, imagine log of x base 8 equals log of y base 8. So don't you think that anybody would conclude that x and y are actually the same? Imagine log of x base 8 equals log of y base 8. So that tells you that x and y are the same thing. Otherwise, their logarithms would not be the same. So when we say x and y are equal to each other, so let's go back and start from here. Y is equal to x. We just figured out. So that means that 8 to the exponent of log x base 8 is actually equal to x itself. So I'm going to say 8 to the exponent of log of x base 8 is equal to x itself. Now the thing is that instead of 8, we can have 9, we can have 10, we can have 10 million. It doesn't matter. So generally speaking, if you have a raised to the exponent of log of x base a, that is going to be equal to x itself. And this is how we come up with these three formulas for logarithm. There's a whole bunch of formulas known as laws of logarithm, which I'm going to explain in the future lectures. But right now, on spot, we came up with 3 of these laws of logarithm, basically. Okay, next one, log of a million. So a million is 10 to the exponent of 6, actually. And the base of logarithm, some people may think we forgot to write, but we didn't. This is actually common log. So the base is understood to be 10. Therefore, the answer is going to be 6, because only 10 to the exponent of 6 is equal to a million. Ln of e, well, ln of e is actually log of e with the same base of e. That's natural logarithm of e. Well, it's going to be equal to 1 according to the second formula right here. 1 over 10,000, that is actually 10 to the exponent of negative 4. You can say this is 10 to the exponent of negative 4 in reality, and the base is 10. So you're asking yourself 10 to the exponent of what equals 10 to the exponent of negative 4? Well, the answer is negative 4, back again. Therefore, common logarithm of 1 over 10,000 equals negative 4. And I don't know if you noticed, I repeat again, I'm not touching a calculator. You see that? So markers in my hand. Not touching the calculator. Logarithm of 0.001 equals what? Well, 0.001 is actually 1 over 1,000, right? So I'm asking, what is that exponent? That 10 is raised to that exponent, and the answer is 0.01. The answer is -3, because 10 to the exponent of -3 is actually 1 over 1,000, which is what we have here in decimal form, clearly. Therefore, common logarithm of 0.001 equals -3. Now, mind you, if you ask me what is log of 54, common log of 54, I'm going to say, I don't know. I'm going to say, I'm sorry. I know I never touched the calculator, but when you ask me like a question like this, log of 54, I got to use the calculator. So I'm going to punch in the LOG button. The base is, of course, 10. Clearly, it's common logarithm. 54, I got 1.732. I hope you got the same answer as well. Of course, this is approximately that much. Okay, so that's how you find the common logarithm. You press the LOG key on your calculator, and this LN key gives you the natural logarithm. Let's say you want to find natural logarithm of 3. You're going to press the button beside it. So ln of 3 equals 1.098 roughly, and this is how you use the calculator to find common logarithm and natural logarithm. Okay, I hope you understood how we are evaluating logarithms. I hope you learned these 3 laws of logarithm, but more will be coming shortly. Thank you.